Is my screen visible? Okay, so let's start. So, good evening and welcome everyone to sixth weekly problem solving session of the problem solving session of week six. So, in this session, we will discuss questions from the concepts taught in week six and some questions from previous assignment as well. And the complete solution will be discussed the in the next tutorial session that will be held on Tuesday. So let's start with it. So first question, this is from your present assignment only. So uh, the question asks that you need to uh, calculate the power delivered by all the energy sources in the circuit. That is a 10-volt voltage source, 1 ampere current, and 2 ampere current. So please try it out. Okay, those things will be updated before the final grade sheets and final grades are being awarded. All the glitches will be corrected. Our team is working on it. Okay, so let's see the solution for this question. So what we can do is so this question consists of mainly of the current sources, so it's easier to apply KCL at each node and get the values of current in each branch and then proceed with the question. So what we need to find is the current that is flowing through this 10 volt voltage source and the voltage developed across these current sources. And please make sure that you follow the passive sign convention because you need to find the power delivered from these sources. So you need to find the current that flows that comes out of the positive terminal of the 10 volt voltage source, and the voltage that you need to find across these current sources should be such that the current that these current sources are providing should come out of the positive terminal of the voltage developed. So if we look at this node, so 1 ampere current flows from here and 2 ampere current flows from here. So through 1 ohm resistor, 3 amperes of current will flow. And uh, yeah, from and this again, this over here will be, so this 3 ampere current will come from so okay, let's uh, assume its current to be some I10. So the current flowing from 3, so the current flowing from Okay, regarding the solution posting and all, we will notify the team, and this will be taken care of uh, from in the future. So for now, let's look at the live solving sessions, and so let's consider the current that flows in the 10 volt voltage source branch as I10. So the current that flows through this 1 ohm resistor will be of 3 amperes plus I10, and since 1 ampere current is flowing from this node, so at node N1, if we apply KCL again, so we will get 3 plus I10 minus 1 is the current that is flowing through this 1 ohm resistor. So we have the current that is flowing in this direction is 2 minus I10. Now, if we try to apply the KVL in the outermost loop, let's call this loop L1. So let's take this to the next page. So let's call this loop L1. If we try to apply the Kirchhoff voltage law in this loop, so what we have is the 10 volts minus 3 into, sorry, minus 1 into 3 plus I10 minus 1 into 3 plus I10, and the current that was flowing in this 1 ampere 1 ohm branch is 2 minus I10. So minus 1 into 2 minus I10, and the same current flows through this 1 ohm resistor also. So minus 1 into 2 minus I10 is equal to 0. So if you solve this, you get I10 as equal to 0. I10 is equal to 0 because this is 3 plus 3 plus 2 plus 2, that is equal to 10. So the current that flows in the 10 volt voltage source is 0. And since you and from there you can find the current that flows through this 1 ohm resistor, that comes out to be 3 amperes because I10 is 0. So the voltage developed across uh, all the 1 ohm resistor that are there on the top of uh, 1 amp current source is 3 volt, 3 volt, and 3 volt. So the voltage developed across this 1 ampere current source is 9 volts. Similarly, if you calculate the voltage developed across this 2 ampere current, that comes out to be the voltage that is developed across this 1 ampere current source, that is 9 volt, plus the voltage that is developed across these two 1 ohm resistors. So that comes out to be, so V 1 ampere is equal to 9 volts, and V 2 ampere is equal to 9 volts plus 2 volts plus 2 volts. So that comes out to be 13 volts. So the power that is delivered by the 10 volt voltage source is 0 because the current through that source is 0, and the power that is delivered by the 1 ampere current source is of 9 watts, and similarly power that is developed by delivered by the 2 ampere current source is 13 into 2, that is equal to 26 watts. So yeah, uh, so let's move to the next question. So we need to find the power that is supplied by the 21 ampere current source in the network given. So please try it out. So let's see the solution to this problem. So again, it is only consisting of current sources. So KCL will be the correct thing to do. So let's see. So let's number the nodes. So let's call this node N1 till N4. Now at this node, this particular node N2. So what we need to find is the voltage developed across this 21 ampere current source, and after that, the product of that voltage and the 21 amperes will give you the power that is being delivered by this current source. So let's assume that voltage to be V21, and if that voltage is developed across the current source, which is in parallel to this 1 ohm resistor. So the current that will be flowing through this 1 ohm resistor will be V21 divided by 1 ohm. So let's call this as V21 only. Now at node N2, if we apply the KCL, we get the equation as I1. So let's call the this current as I1, and let's call this current as I2. So at node N2, if we apply KCL, we get I1 plus V21 plus the 3 amperes that is flowing inside the node is equal to 21 amperes that is flowing outside the node. So we get an equation as I1 plus V21 is equal to 18. And similarly, the N1 at node, similarly, when we apply the KCL at node N4, we get this. So first of all, at N1, since 3 ampere is flowing outside and 9 ampere is flowing in, so from this 1 ohm branch, 6 ampere will flow outside. So considering that, the total current that so applying KCL at node N4, we get I2 plus 6 amperes is equal to I1. So from there, we get value of I2 as I1 minus 6. And if we apply KVL in loop L1, so we get I2 into 1 plus I1 into 1 is equal to V21. So, and if we substitute values of I2 in as equal to I1 minus 6, we get the second equation. So solving these two equations, we get the value of V21 as 10 volts, and the power that is being delivered by the 21 ampere current source is 21 into 10 volts, that is 210 watts. Yeah. So, Dinesh, do you have any doubt? Your hand is raised. Can you please unmute yourself and ask the doubt? Okay, so let's move forward.
Hello, sir.
Yeah,
Uh, Sir, can we not convert this delta into a star?
yeah, you can do it in any number of ways. I mean, since it has many, almost all, since all the energy sources are current sources, so I found it convenient to use KCL in whatever uh, network we have. But if you want to do it that way, yeah, you can do it.
Okay, sir.
So, uh, so let's discuss a few questions from sixth week content, that is related to Thevenin, Norton, and maximum power transfer theorem, and some two-port network questions. So the first question is that you have been given a network as shown in the figure, and you need to find the open circuit voltage, that is VAB, and the input resistance looking from VAB, that is R from this AB uh, port, that is equal to RAB. So you need to find these two. Please try it out. Okay, so let's see the solution for this. So for finding the open circuit voltage, we can rearrange the circuit as follows. So this branch can be moved over here, and if you do that, you get the following circuit for. You can visualize this circuit as the circuit drawn below. And in this case, as you can see that since this is open circuit, so no current will flow through this 2 kilo ohm resistor. So no voltage will be developed across this. And apart from that, so since I from this node is I in this branch is zero, so all the current that is generated by this 8 volt voltage source will be equal to will be flowing in this loop itself. So from there, you get the value of the current that is flowing in this loop as 1.25 milliamps. And since hence the voltage developed across this 4 kilo ohm resistor is 5 volts, and no voltage will be dropped across this 2 kilo ohm resistor. However, since this is an ideal voltage source, so this will create a 2 volt drop from node A. So from node A to node B, if you apply the KVL, so you get uh, VA minus 2 plus 5 minus VB is equal to 0. So from that you get VA minus VB is equal to 3 volts. Any doubt in this? Okay, so let's move to the next question. So okay, so next was to find the equivalent Thevenin resistance in this uh, of this network. So that will be basically you will have to de-energize all the current and voltage sources. So voltage source will be short circuited and the current sources will be open circuited. Since there were only voltage sources in this network, so this 2 volt voltage source over here that has been shorted, and the 8 volt voltage source over here is also shorted. So apart from that, you have this resistive network, and if you find the value of AB, and there is 2.4 and 4 kilo ohm in parallel, and that in series with the 2 kilo ohm resistor, so that comes out to be 3.5 kilo ohms. So yeah. So again, in this question, it is the demand of the question is similar, that you need to find the VAB, that is the voltage between the node A and node B, and you have to find the equivalent RAB, that is the Thevenin resistance of this circuit. Please try it out. Okay, so let's see the solution for this. So first of all, finding the value of VAB. So again, this 2.4 kilo ohm and 2.4 kilo ohm on either side will have no significance, and will have no voltage drop across them. So what we can see over here is that if so these since this is an open circuit node, all both A and B are open circuit nodes. So this 1 ohm and 1 ohm for this case is in series. So the total equivalent resistance that you get from this 3 ohm and this 2 ohm in parallel is of 1.2 ohms. So sorry, 1.2 kilo ohms, and since 1.2, 1.2 are again in series, so the voltage developed across these two terminals is 6 volts. And since in on the right side also you have an identical network, however, the polarity of the voltage source has been reversed, so you get another 6 volt from this side as well. So the total VAB that you get is of 12 volts. Any doubt in this? So this is how you needed to find the open circuit voltage. Now for finding the value of RAB, that is the open circuit resistance, what you need to do is you need to uh, de-energize all the voltage source, that the 12 volt and minus 12 volt voltage source have been de-energized. So what you have now is that this both of them are identical. So what you have is if you find the equivalent resistance of one side, you can just multiply it by 2 and you will get the value of RAB. So 1.2 volt and 3 volt in parallel, then you get the value as 3.6 divided by 4.2, then 1 ohm in sorry, not volt, ohms, kilo ohms, then again 1 kilo ohm in series to that. So from there you get the value as 7.8 by 4.2, and then again 1 kilo ohm in parallel to it. So and on top of it you have 2.4 kilo ohms in series with that, and that you multiply by 2 because you have two such networks. So from there you get the value as 6.1 kilo ohms. Any doubt in this? Okay, so let's move forward. Now, again, in the same question, if you need to find the short circuit Norton current, please try find that thing quickly.
Sir, previous assignment, 10th problem. Hello.
Yeah, previous assignment, as in
10th problem, you are given an answer. It is milliamps only, it is minus 6.4 will come. Your unit it is given in the assignment question is it is in amps. So answer given is
previous.
minus 6.4. Minus 6.4 answer is correct, but the unit is milliamps. If you are giving answer is in amps means you have to change 0.0064.
Yeah, okay.
That correction you just to do it, sir. At least I say I intimated through mail. Not even I am not getting any reply also.
Yeah, so we have
No,
actually the thing is that we are the PMRFTAs, and actually we are not okay.
no, that's
So they
okay, sir.
shouldn't.
That's okay. Then
Yeah,
to whom we contact, we don't know.
yeah,
Nothing is
yeah.
there.
We have
Continuously we are
we
sending
have
the mail to you, but we are not getting any reply. Then what is the meaning of forum is there? Then in the feedback you are asking whether a forum reply is there or not means. Continuously feedback also given. If any action is taken now, okay. Action also not taken means what?
okay. I get your point. So
No,
this will be
I am
intimated
not
to the
pointed.
professor.
I am not pointing you to whom the
No,
responsible
no.
person I
I
can
am
contact.
saying that's what I will intimate this thing to the professor of the course, and he will take the necessary actions.
Yeah,
Please
just
be assured for that.
change the check the answer. It is milliamps actually. Unit is given in amps only. So if it is amps means 0.0064 will come.
Yeah, understood. Okay, so let's see the solution for this. So one way is that you can short this thing and traditionally find the value of the current that flows in this branch. However, since in the previous two questions you have already found the RTH and the V open circuit, so from there the short circuit current you can get as the whatever Thevenin voltage you found and whatever Thevenin resistance you found, you can just divide it and its ratio will give you the short circuit current, that is the Norton current. So that comes out to be 1.967 milliamps, that is approximately equal to 2 milliamps. Any doubt in this? Okay, so let's move to next question. So in this, you need to find again the open circuit voltage across the terminals VA and VB. Please try it out. Okay, so let's see the solution for this. So we have over here is what we have over here is again this 6 ohm resistor is of no significance as no current flows through this. So what happens is the complete 3 ampere current that we have over here flows through this 3 volt flows through this 1 ohm resistor as the current flowing as the node A and B are open circuited. So now we have been given that the current that is flowing through this 4 ohm resistor is Ix. So the current that flows through this dependent voltage source will be 3 minus Ix, and the same current will flow through this 5 ohm resistor, and the voltage developed across this 5 ohm resistor and so be 5 into 3 minus Ix. Now if we apply the KVL in the in this particular loop, what we get is the 2 volt voltage source plus the current that the plus the voltage that is developed across this 5 ohm resistor, that is 5 into 3 minus Ix, plus 2 into Ix is equal to the current that is developed across this 4 ohm resistor, that is 4 into Ix. So from there you get the value of Ix as 17 by 7, and hence the voltage developed across this complete node will be the Ix times 4, that is equal to 4 into 17 by 7, and additional 3 volts will be added to it because of this 3 ohm resistor across which 3 ampere current is flowing. So final answer comes out to be 12.71 volts. Any doubt in this? Okay, so let's move forward. So now in this question, you need to find the Norton equivalent with respect to terminals A and B in milliamperes. Okay, so let's see the solution for this. So what we can do is, since we have three current source, three voltage sources with some uh, internal resistance of them in series, so we can use the impedance transformation and convert these into current sources. So if we do that, what we get over here is 3 ohm, 2 ohm, and 1 ohm will come in parallel, and the overall current that will be flowing from this will be 5 by 3, that is due to this minus of 2 by 3, as the sign of this voltage source has been inverted, plus 1. So uh, the total, and to find the current, and what we need to do is we need to find the short circuit current that is flowing through this branch. So what we can do over here is, instead of looking this network as a network of resistance, we can look it as a network of conductances. So if we convert all these resistance into conductances, that is the one reciprocal of their value of resistances, what we have as the current flowing through one of the branch, that is the 5 ohm branch will be G4 divided by G1 plus G2 plus G3 plus G4 into the total current, that comes out to be 7 by 6 from here. So if and all the conductance as discussed is the reciprocal of the value of resistance. So this expression you get for the Norton current, and that comes out to be 114.75 milliamps. Any doubt in this? Okay, so let's move to the next question. So in this question, you need to find out what will be the what will be the what can be the maximum power that this load resistance can consume. So this is a varying load resistance, and this can take any value. So first of all, what value this load resistance should have, and on top of it, what for that load resistance, what is the power that this will consume. So basically, like what load resistance must be so that this consumes maximum power. So I hope you people are aware of maximum power transfer theorem. That let's say uh, you have an equivalent, equivalent of this complete network. You have let's say a voltage source in series with some resistance. Let's call it RTH and VTH. So and you have a load that is connected to this. Let's call this RL. So in this case, the maximum the power that is being delivered to this RL, and the let's call it as PL, will be maximum when RL equal to RTH. And what will be its value? Its value will be VTH by 2 whole square divided by RTH. So if you try to apply this in this, so basically you need to find both the RTH and VTH of the network that is there on the left side. So for finding the VTH, or let's call it VAB, so what we can do is the two voltage sources with non-ideal non-ideal resistance. So previously we saw that we can do it by transforming it to by doing impedance transformation. However, another thing that can be done is that so if you have, let's say, two voltage sources there with some non-zero internal resistance V2 R2. So In this case, the equivalent equivalent voltage uh, that is developed over here, that can be calculated as V1 R2 plus V2 R1 divided by R1 plus R2. And the equivalent resistance that this will be seeing is R1 parallel R2. So if you do that, you get so if you apply it on this particular network, you get this equivalent voltage and resistance in series. So the value of voltage comes out to be 7 into 4 minus 2 into 4 divided by 8, that is 2.5 volts. And 4 and 4 ohms are in parallel, so it comes out to be 2 ohms. And that is in series with 3 ohm resistor. So uh, this and again, no current flows in this direction, as the VAB is an open circuit node. And since all when the current of zero point 0.5 ampere flows through this 5 ohm equivalent resistance of 2.5 volt voltage is developed, and due to additional 2.5 volt voltage, the total VAB that you get, the total Thevenin voltage you get is equal to 5 volts. And if you calculate the RTH, that again comes out to be 5 ohms. So 2 ohms and 4 ohm and 4 ohm in parallel and in series with 3 ohms. So this is the equivalent network you get: a 5 volt voltage source with a Thevenin resistance of 5 ohm, and then the load resistance for maximum power transfer you will need as 5 ohms. And if you uh, apply, okay, the voltage that is developed across this is 2.5 volts, and the power that is being delivered to this load resistance is v square by r, that is 1.2 volt 1.2 watts. Any doubt in this? Okay, so let's move forward. Now this is a question of two port network. So you have been given a two port network in the question, and you need to find the admittance parameter matrix. So please try it out. Okay, so let's see this. So the admittance parameters can be found as follows. So basically, what we do is we write the two port networks port equation in the following form. So we have V1 is equal to Y11 times I1 plus Y12 times I2, and V2 is equal to Y21 times I1 plus Y22 times I2, where I1 and I2 are the current flowing inside the two nodes, and V1 and V2 are voltage developed across the two nodes. So let's try to find out the parameters one by one. So first of all, for Y11, in that case, what we can write is uh, what we had was V1 is equal to Y11 times I1 plus Y12 times I2, and if I2 is set as 0, that means this node is open circuited. In that case, we can get Y11 as V1 by, sorry, sorry. Okay, it's I've written the impedance matrix, not the admittance matrix. So we have to find the admittance matrix. So what we need to do is we need to find the values of I1 and I2 in terms of V1 and V2. So now Y11 is equal to I1 by V1 when V2 tends to 0. So V2 tends to 0 means this node, the port 2 is short circuited. So, and if we do that, then this 3 ohm resistance is of no use. So, what we need to find is, let's say we apply some voltage source V1 at this node, we need to find the current that is flowing into this node. So now since V2 is 0, so again this CC, the VCCS will be an open circuit. So what we have finally is 2, then a voltage source of 4 times V1, and then this is a short circuit over here. So what we have in this loop is V1 minus 2 times I1 plus 4V1 is equal to 0. So V1, 5V1 equal to 2I1. So we have 5 by 2 as Y11. So we have found Y11. Now similarly Y22, that is so uh, now okay, Y12 will be what we need to do is we need to short circuit this node and find I1 when we apply a voltage source of V2 at this node. So in this case, so since this is a short circuit, so all the current that this voltage controlled current source will be providing will go to a zero resistance path. So that will just flow in this. So again, this uh, anything in parallel to short circuit is of no significance. So what we have over here is I2 can be written as so there will be V2 by 3 ohms that will be flowing over here, and let's call this voltage, and this voltage source again will be 0 as V1 is 0. So what we have over here is I2 can be found out by a 2 ohm resistor and a 3 ohm resistor in parallel to V2. So the admittance, so since you need to find the admittance, that will be opposite or reciprocal of the resistance, so that will be equal to 2 plus 3 divided by 2 into 3, that is equal to 5 by 6, that is y12. So, and minded that volt that again okay, that you also need to keep in mind the direction in which that uh, thing is flowing. So sorry, this is not y12, this is y22. So you have found y11 and y22, and y12 and y21 are nothing but so in this particular network, whatever current is flowing in this direction, that is equal to I2, so that is equal to minus of I1. So I2 you have as minus of I1, that is equal uh, y12 in this case will be equal to minus of y11, hence is equal to minus 5 by 2. So, and similarly you need to find this current, that is I1, in order to find y21. So that will be that can be done by current division. So that is, this is I2 times I2 times 3 by 5, that is equal to V2 into 3 by 5 into 5 by 6, that is equal to minus of 1 by 2 times V2. So Y21 you get as minus 1 by 2. So these are the, sorry, I think there is some mistake in finding 3 divided by 3 plus 2, and okay, so what we have over here is y11 equal to 5 by 2, y12 equal to minus 5 by 2, and y21 equal to minus 1 by 2, and y22 equal to 5 by 6. Any doubt in this? Okay, so this was it from my side. And regarding all your concerns of the reply on forum and the corrections of the solution, so that will be intimated to the professor, and they will take the necessary actions for that. So, any other thing?
No, you just upload the answers for the assignment, sir. No, the way which
Yeah,
you
yeah.
solve that, we have to check it out. Even though we are attending the meeting, it is better you just upload the assignment answers so that at least finally we can prepare and do the corrections.
Understood.
Okay.
So yeah, that will be taken care of. We have intimated the professors, and they will take the necessary action. So yeah, this was it from my side. Thank you for attending.